guys, tomorrow's review, so today's the last day of content, and all of it is stuff you have learned and seen before. Today we're covering natural logs, and I need a page of notes. Start on the study guide side, and you can kind of read all that on your own time, but let me give you the highlights. Logarithms with the base of e are called natural logarithms, and they're usually written as ln of the x. So it's just a type of log, and you've got a button on your calculator for it that's on the left. So without words, this is what it looks like. Log base e of x equals natural log of x. So if a natural log is like a regular log, it just has a specific base, all of the rules for logs still apply. So if we have the natural log of a times b, it's the same thing as the natural log of a plus the natural log of b. If we have the natural log of a divided by b, it's the same thing as the natural log of a minus the natural log of b. If we have the natural log of a to the b power, and this is what a lot of you guys forgot on your assignment, you can take the b, catapult it over the top, and you have b times natural log of a. Those laws still apply to natural logs. I like this little study guide because it's got 3 examples kind of pre-done for you, so if you get stuck on your homework, you can always kind of check out those as well. Has everybody written all that down? Almost? Okay. On the other side, we've got some examples to look at. Evaluating the expressions, basically type it in your calculator. I know you can do that. We're not even talking about anti-natural logs because we don't have that much time to cover all of that stuff. Number 7, converting each logarithm to a natural logarithm and evaluate. I'm just going to do one of these. It is not that big of a deal. I hope you remember from last year the law of common logs, and kind of what that is that you can take this, and I kind of talked about this a second ago, and you can turn that into log base 10 of 94 over log base 10 of 7. And that's handy because your calculator, you've got a log button, but it doesn't allow you to change the base just by pressing log. So if you can hit that, there is a program that will do that, but we're not there. For most calculators, there's just a regular old log button for common log. And that's where this kind of came from, is they needed a way to be able to kind of do that without having to change the base, or without making 7 the base, I guess I should say. So we have log of 94 over log of 7. Well, you're allowed to do that because the bases match, which means if I wanted, I could make that log base e of 94 over log base e of 7. Well, log base e we just found out is natural log, so we have natural log of 94 over natural log of 7. So if you've got a professor someday that asks you to convert it, that's how you do it. We won't be doing that today. Number 10. That's blurry. That's driving me crazy. Now in the directions, it says to use natural logs to solve the equation or inequality, so that's really what we need to do. Your steps are part of your answer today. I realized we could use regular logs, but we're going to use natural ones because they said to. So there is a rule that says, as you guys know, whatever you do to one side, you just have to do to the other. So if I wanted to, I could say natural log of 6 to the x equals natural log of 42. Because whatever I did to one side, I did to the other. Totally legal. What do I do with this little exponent? How do I bring him down? Throw him over the top, right? So now we have x times the natural log of 6 equals the natural log of 42. How do I get x by itself? Divide both sides by natural log of 6. You can just type that in your calculator. So natural log of 42 divided by natural log of 6. You guys type that in and let's see if we can get the right answer. Somebody borrowed my calculator. Oh, I forgot to evaluate this guy on the top. I'm sorry. That answer was 2.33. Sorry about that. What did you guys get on this number 10? Yep, 2.08, and if we kept going, it'd be like 60 or something like that. So there's x. Questions on that one? Everybody okay? Number 7 works very similarly. Or 11, sorry, number 11 works very similarly. So we can say natural log of 7 to the x equals natural log of 4 to the x plus 3. I want those exponents to not be exponents so that I can mess with them. So let's throw them over the top so that I have x times natural log of 7 equals x plus 3 times the natural log of 4. Why did I put x plus 3 in parentheses? The whole thing is being multiplied by it. If you don't, it's just going to say x, and then plus only 3 would be multiplied by the natural log. I said that last hour, and I had like 3 or 4 kids come up to ask me questions like halfway through their worksheet, which is fine, and every one of them left out the parentheses. Don't leave out the parentheses. Mathematically, it doesn't mean the same thing. You can't do that. You have to have the whole thing times natural log of 4, so be careful. Now, if you wanted to, you could distribute this natural log to both of those, but I think you're making that problem even longer than you have to. I say let's divide both sides by natural log of 4. So that on the right-hand side, we just have x plus 3. If I type in ln of 7 divided by ln of 4, I think we get 1.4-ish, right? 1.4037, I think, x. And this is what kills me. By the way, you can cross out 14. We're going to use that workspace. Here's what kills me on these problems. Like, you guys are whizzes at all the trig stuff and the log stuff, and then you get this far, and you're like, I don't know what to do. I think the big, long decimals freak you out. I don't know why. What should we do to this one? Subtract 1x from both sides. When you subtract 1x from both sides, you get 0.4037. X equals 3. Now what? Divide. Yeah. Same process as always, but just have nasty decimals, and that's okay. So in the end, I think we get 7.4317. Hope somebody's checking all that. I only think I did that right. Any questions on 11?
So X is
No. Not in this one. E is 2.7. Number 12. Now, a kiddo last hour had a great question. He was like, he said, I didn't do well in these last year, and I just kind of need to cut and paste. What do I do every time? Which, I mean, they're all really different, so you can't really do cut and paste. But I can tell you, if there's E in the problem, if you put an LN with it, it kind of poof disappears. If there's an LN in the problem, if you put an E with it, poof, kind of disappears. We're doing some magic. So top right-hand corner, I need you to write a couple things down. The natural log of E equals 1. That's a rule. The natural log of E equals 1. And here's why. Natural log, that means log base E, yes? So I replace natural log with log base E. There's a 1 here we can't see. And yesterday we talked about how when the base of the exponent and the base of the log match, the answer is the exponent. And I showed you how that was true. You pick up the base, toss it across the river, you have E to the first. So that's why that one works. So you need to know this little guy here. Also handy, if you've got natural log of E to the x, it's just going to equal x for the same reasons. Because natural log is log base E. When the base of the exponent and the base of the log match, then it's just the exponent. So be ready for when you see that on your assignment. One last one. If you have E raised to the natural log of x, the answer is x. And here's why. If I turn this whole problem into a logarithm, well, the base of the exponent becomes the base of the log. The other two guys trade places. Remember this from yesterday? The exponent gets to be over here big and bad by himself. He likes that. So what we have here, log base E, that is natural log. So natural log of x equals natural log of x. So that does work. So my point is, when you have E next to natural log, poof, it's like it disappears. It becomes a 1. It just sort of blends in. So we're going to do some magic today. Does that make sense? So let's go down here. I see an E, and I know that if I can get a natural log next to it, it's going to go away, and all I have left is the exponent. The problem is I've got this guy in my way. How can I get rid of that 175? Divide both sides by 175. And do we get 7.1371? Okay, this is the part where you get to do your magic. I'm going to put a natural log in front of both of them because whatever you do to one side, you have to do to the other. When I have natural log next to e, poof, disappears. So on the right-hand side, all I have is negative 0.04t. On the left-hand side, I can type that in my calculator. Natural log of 7.1371, and I should get 1.9653. Then how do you get t by itself? Divide. And I believe you should get negative 49.1328. I don't know, she's kind of wise because all of these numbers are super tiny and I like things to be as accurate as possible. So if there's an E in the problem, find out how to get it with an LN. If there's an LN in the problem, find out how to get it with an E. Let's look at 13. This is no different, it's just an inequality, so just be careful. Why don't we stick natural logs in front of both of them? Now what? Yep, catapult those exponents to the front. Don't forget parentheses, please. You could distribute over here, but I think you're asking for trouble. What would be smarter? Divide both sides by natural log of 10. Absolutely. Somebody tell me, what do you get? 0.4771? Is that right? X, yep. Now what? Subtract 1x from both sides. Now how do you get x by itself? Divide by the gross decimal. 1 divided by that gross decimal. You get negative 1.9125-ish. And if you want to rewrite it, oh, whoa, what did I do wrong?
You gotta flip it. You gotta flip it.
Gotta flip it. Why do we flip this little guy? Yeah, we divided by a negative. Thank you. And if that freaks you out to write it with the x on the right, you can flip it and say x is greater than negative 1.9. Questions? This came from over here when I subtracted 1x from both sides. So you're subtracting 1. It's kind of like if I had, guys, x plus 1 is greater than 5x. Subtract 1x from both sides, right? And it becomes 4x. I have x plus 1 is greater than this number. Subtract 1x and you get that. If the decimals weird you out, think of that as 0.4x. 0.4x minus 1x is negative 0.6x, right? Yeah. Yeah. Does that make any more sense, Deanna? Yes? Tiff, you okay? Okay. All right, this little guy here, I see an E. What do I do to get rid of it? Put it with an ln. Whatever you do to one side, you have to do the other. So now I have a natural log of 8.4, which is 2.1282. These guys go away, and I'm left with t minus 2. Add 2 to both sides. Questions on any of that? Word problems, they're all the same deal. You're still solving for an exponent using natural logs and e. It's just got words. So it's like yesterday, you just plug it in, use some reading comprehension, and then solve for your exponents. Let me kick this off and then get your assignment.